Well, hello, friends. Today we are going to make a chroot in Serenity because yesterday when I was working on the stuff about putting the lookup server in a separate user account and everything, which we can see here, lookup server now runs as lookup. It kind of annoys me a little bit that that the lookup server is still able to access the file system, even though, let's see, like if we are lookup, we can still see stuff. And if someone were to compromise the lookup server by messing with DNS responses or something like that, then they could conceivably get access to files. So I was thinking today we would do chroot, and then we would use that to give lookup server a very, very limited view of the file system. And of course, I realized that chroot in itself is not a complete security mechanism by any means, but it's a thing. It's like one layer of something. And if we can just stack tons of these layers, then we can reduce the surface of what we expose. So I think it would be a good thing to do, and chroot is just useful to have in general. So that's what we're going to do today. And I guess we should have some sort of a directory for him to sit in. So I'm thinking it would be like var lookup maybe. So let's see, I guess we gotta make sure that we have that directory. So mkdirp mint var lookup. I think we'll do that, and then we're gonna chroot him into there. And maybe the first thing we can do is just, or what are we even gonna do? I guess we'll need a chroot command for testing this. So I think we can maybe copy a shell into there as well, just for testing. We'll copy the sh. What is that? Sh. Shell. Or lookup bin sh. I don't know. This is just for testing. We're just gonna try to make a chroot command that can go in there. Let me just see that that looks somewhat sensible. So of course, by the way, if you're not familiar, chroot is a syscall in Unix that changes the current process's idea of what the root directory is. And it's something that only root can do. I mean, the root user. So the idea here is that we're gonna chroot ourselves so that the new root directory for the lookup server process becomes var lookup. And then if you are the lookup server and you try to open any files, all the path resolution will start from var lookup as if that's the root. And of course, then it won't be able to find anything. And it's a pretty neat syscall that can be used for a variety of things like build systems and testing various things, but also to isolate a little bit a process. So anyway, let's add the syscall to the process class. We'll just put it here at the bottom. Chroot. I feel like chroot is just a path, right? So I'm working on some new types for syscall arguments. So let's see. I guess, does this make sense? This is not actually going to make sense. So we'll do it this way: path and size t path length. That will be our syscall. And let's go and add it to syscall.h. Okay, now chroot officially exists. Okay, and then we gotta validate. If not validate, read. Default. Man, default is like the most important error ever, I've realized, after getting owned in the CTF thing. Because if you don't return default for bad addresses, you are gonna get so screwed. So it's almost like I would like to figure out some way to systematically check for this rather than relying on doing it everywhere manually, but I'm not quite there yet. We'll figure something out though. Maybe some kind of code generation or something. So what kind of errors do we need here? I guess basic path lookup stuff. We want to be able to open it. It has to be a directory that we can open, right? So it's very similar to chdir in a way. So we can do a lot of the same stuff as chdir does. I'll call it user path. User as in user space. Okay, so we open this directory, and if it's all good, and of course we have to be super user in order to do chroot, so if not is super user, return perm, right? Yeah. Okay. We'll say root. That'll be pretty good. Of course, this means that literally everything in VFS has to change so that it takes a root argument, because we have not been doing this kind of stuff before. Or maybe we can actually look at the root of the current process. That's another option. What am I thinking about? VFS root custody. Right, so this is what we're normally using to do path resolution. In resolve path, we always start with the root custody for anything that starts with slash. So let's see. I guess we'll start by just adding a member to process. Next to the current working directory, we'll add a refer custody root. And we will inherit the root. Okay, there we go. And then we have to make sure that we use this now. So in VFS, instead of using root custody here, we should use the current process root. So we have to expose this. And CWD, no? I thought we exposed that somehow. Maybe we don't. Well, it don't matter. We'll expose it now. So we'll say const custody root or root, whichever. Okay, and then root custody is, no, we should always use current process root. Root custody is now only relevant when we're starting a new process, and I guess for some other stuff, but let's see, mcwd. So this, I mean, this, I already can tell that this is not going to do the whole trick if we do it this way, because we also have to stop path resolution when we get to the current process root, but we'll get to that in a moment. Let's just make a utility for this. Where is chroot anyway in the man pages? UniSTD. All right, my favorite header. So the syscall goes something like, where do we put it? Maybe here. Int chroot const char path. And the implementation is chroot const char path syscall sc chroot path strlen if path. No, not you. Return with error now rc, and then if path is null, we can just say default, then we don't call strlen on a null pointer. So a little compromise. Okay. So usage chroot path. RHV1, and then we'll say pair chroot, and it will probably fail because you're not super user, of course. So what does the utility in Linux even do? I think it starts with shell, right? What is that, section 8 or something? Run command or interactive shell, right. So in our case, we'll just run bin sh in the root. So I gotta start doing this instead of this RC thing. Because I don't know why I always insist on storing it in a variable when it's not useful in any way. So we go to slash. Something like that. XFL bin shell. No, well, okay, that's pretty good. Wow, taking your sweet time here. Guess we might as well rebuild the kernel while we're at it. What are you doing, computer? Just OBS stuff, I guess. Right, no chroot yet. Dang. All right. Okay. Relink the userland. sync and run. Okay, so we're already screwing up. I guess I'm trying to use the current process root before I've set it, because we are in ksim load. So load ksims, loading the kernel symbols, probably before we have anything like that set up. We've just mounted root here, but the current process does not have a root, so we'll let's see, BFS root custody. We'll have a way to set the root explicitly. I think that would be good. Root is root, and we can actually use that here because it'll look nice. And then we need custody in where exactly? Oh shit, actually we can't do that. Or wait, why can't we do that? Process.h, I guess I should have out-aligned it, yeah. Alright. In case you're not familiar with custody, by the way, I talked about it in the file system code tour video. So custody describes a relationship between a directory and one of the entries in the directory, or it's a parent-child relationship, hence the name. And it's just a way to in the kernel store a sort of a reference from a directory with a name to one of its children. Okay, what else do we have going on here? So we're trying to open something, but we cannot. I'm assuming that we still have a null custody somewhere. Find shebang interpreter. Open. So this is a new process. In the new process, we need to do this way sooner, I guess. Exec. Wait, hold on. We're in the exec syscall in system server. So why wouldn't we already have a root set? M root equal root. Oh, we had current directory. Okay. I see how that works. So the first time you call this, it initializes it that way if you don't have one set. So maybe we should do the same. Something like this. And maybe we should call it root directory instead. But root is pretty nice. Although root is overloaded with the super user, so let's call it root directory. Okay. Ambiguity gone. If m root directory is VFS the root custody return m root directory. Cool beans. And there we go. Of course, I have to update this. Queue Creator is pretty good updating the whole code base if I change something, but it's not perfect. So what seems to be the problem here? I'm passing a const custody and he doesn't like it. Resolve path takes a custody amp. Well, custodies are not terribly mutable, to be honest, but I guess we could live with exposing a mutable custody on the process for now. We'll do it that way. Or actually, let's do it that way. Let's be const correct here, gentlemen, ladies. Yeah, so if you can't open the directory, we're sure as heck not gonna let you chroot into it. That should already work. Okay. All right, we are live. So let's go to var lookup. Of course we can't because we're not root, but what if we were? Okay, it now thinks we are in var lookup. But, oh wait, hold on. I changed root to there, but what happens if I go to slash? Oh shit, that actually does work, okay. But I can go to dot dot, and I'm still here. Oh, how cool is that? And that kills us because oh shit, the custody cache breaks because of this, of course. So we have a custody cache that and if you're in a different chroot, then you can't use the same custodies as the cached ones. Interesting. I had not really thought about that. It was never really clear to me how to cache custodies anyway, but it seems like in this case, like we can't cache because the custody cache sort of assumes that everything can follow its parents up to the root directory, but that's not really going to be true here. So let's see. Or wait, am I just being stupid now? Resolve path, get or create. What was I actually trying to do? The command I typed was ls bin slash. So if I go into that directory, then we crash. Cached custody for name bin has right, because we're looking at the custody for slash bin. But maybe what we should be doing is, I mean, we still want to use the custodies, but how the heck do we just need to figure out how to translate from the chroot here. So let's see. If we're starting from slash, then I guess, let's see, how does this work? So path resolution is this big and chunky thing, and it starts by first checking, is this a absolute path? An absolute path starting with a slash? Otherwise, we think it's a relative path. So for absolute paths, the custody chain that we're going to resolve starts with the root directory, and then it will look at every individual component because the path is split up at every slash, and we call those parts, I guess. So parts of the path, we iterate over all the parts and resolve each part in turn. And for each part that we resolve, we either add something to the chain, the custody chain, or if it's a, actually even if it's a dot dot, we don't remove dot dot. I think we just add it to the chain, but that's probably something that we should get better at not doing. Anyway. When it comes to this part right now, the issue is that this is not the root. So what are we doing here? For relative paths, we take the current base and we append everything, or prepend everything from the current base. So the base is, when you're doing a relative path resolution, so say that you're in home anon, right, and you're looking up the file name X, then what we do here is we go through the current directory, which is the base, which is home anon, and then we add the custodies for home and anon to the custody chain. But since this one is starting with slash, then we only add the first one, but we should probably check here if we do have parents, then we still need to do this. So maybe it's just a matter of going from the root directory, because if we are like at the natural root or the real root, then there will be no parent anyway. So we can, instead of starting at base, we'll just start at the current process root. I feel like that makes sense. Maybe then we can actually use the cache. Okay. Nope, we are still crashing. Okay. So, wait, why does this crash? Oh, I'm not looking. It is a relative lookup. Shit, okay. Okay, maybe the thing we have to do here is bypass the cache for now, and because I don't know how I would like the caching to work. Where do we do the lookups? Get or create? Get or create? So we could always just do a create custody here. It's fine to have many instances of the same custody, it's just wasting memory is all. That doesn't hurt, because we don't use them for identity comparison or anything like that. Okay, here we are. And I guess that's how I ended up creating that data structure. But this is definitely not. Bin. Okay, this is really weird. cd/bin ls. So there is some confusion going on here, because this is like ls shows me the chroot, pwd says we're in slash, but we can look up stuff that's not in our root, so that's not good. Okay, so I'm guessing that we need to do some more business. Yeah, of course, it's right here. It's like I have it right under my cursor, that we're starting right under the root inode. So what we want to do instead is current process root directory dot inode dot identifier. And what else do we have? Inode was at root and head of loop, so we're going to have to fix that a little bit. Say current process root directory. Wait, hold on. Let's cache this root directory thing somewhere. Current root. So it'll be a little easier to follow if we do this, I think. Inode dot identifier equal to crumb ID. The crumb is, I guess it's the inode that corresponds to the current part that we're looking at. They're call them crumbs, like breadcrumbs, like we're following a trail of breadcrumbs here. And let's see. Oh wait, was root. So root can, if we were at root at the head of the loop. Oh, this is for traversing mounts. That code is not super beautiful, but this one we'll have to do differently. So if crumb ID is not the current root inode identifier. Oh, all right. Wow, I get kind of tired just looking at this function. I maybe should look for some way to structure it differently, because it just feels very burdensome somehow. Well, that did not work. What the heck? Wait PID. Wait, what? Reap. Oh shit, the process destruction tears down a custody, and we can't deal with that because we can't delete things that use locks in the process destructor, so we have to do it in the finalizer, which I noticed that we already had this problem here for the current working directory. So this is kind of a peculiar situation. I don't know if I've talked about it in some video, but basically process destruction is happens in two steps. So first, when a process is, we've decided that a process is going to die, then we do this thing called finalize, which is this is a function that we call in the process, but it's called from a dedicated kernel thread that's called a finalizer. So this is what we're asserting here, that we are in the finalizer thread. And what this does is that it allows us to take locks. So the final destruction, like the actual invocation of the process destructor, happens with the CPU interrupt flag disabled. So when the interrupt flag is disabled, we cannot take locks, because if somebody already held the lock, then if we try to take it and it's taken, then that situation is unresolvable because interrupts are disabled, so they can never wake up and release the lock. So because of that, we do everything that requires taking locks, we do in the finalize steps, and then after the finalize step, we mark the process as truly dead, and that's when the Reaper comes and collects him. So there's a bit more to it, but that's the basic idea. So that's what I was doing here, was just clearing the root directory reference counting pointer here to make sure that we, if needed, we run the destructor while we can take locks. No such file or directory. Well, I'm trying to run bin shell, and does that not exist now? Well, what's it called then? Var lookup. Oh, right. Yeah. So, I was screwing that thing up. There we go. And let's see what we can do with this. Ooh. Now we're having some real trouble here. We can't open etc past WD. Okay, let's make etc and etc past WD var lookup etc. Can we chroot now? Okay. So now this is all we can see here. Can we get out of it? Can we get to home? We cannot. That's pretty cool. So it seems that, no, we can run id. How are we running id? Bin id. That still works. Neon cat. Oh, I don't know neon cat. Yeah, like how can I even run ls? I'm not supposed to run ls, and I should have realized a long time ago that I'm running ls this whole time. So why does it find things like ls? ls. I guess we can just look in sysexec. Where does it try to open the thing? Do exec. We'll do a regular VFS open with a base. So we see that it's /bin/ls is the command that succeeds. So bin ID, that succeeds. No relative resolution. So base is irrelevant, but we're coming in here and it's not a create, but we do a resolve path. And why does that work? Let's dump this out. So current path resolution with current root, and then what can we dump out about it? I guess the absolute path. Relative base, and then we'll just dump out the base absolute path. I don't know, I just want to see what we're doing here. Wow, look at all these guys. Current root is var lookup. I mean, that makes sense. current root slash. So we're looking up id path resolution. Current root nothing. I mean, I guess it makes sense that that the current root is empty. Because why? Why is it no? We'll put out what our starting crumb is. So current okay, very, very noisy. So var this is the inode number that we're looking for, 8636. So right, 8636. So go to slash pwd id, and if we look for man, it's so noisy. Where's id? Here, do exec id. Do exec bin id. So it's starting from chrome ID 1, 2, and that's the root of the ext2, like the real root. So why did we get there? What happened to the root that we had, which was perfectly fine? When did we transition? Okay, so this is so noisy. Let's say if current process name is shell. Let's do this. We don't have to look at the other processes. Okay, and then the chroot should only happen that one time. And chadir, which was like right after we chroot, then we chadir to slash. Which is a bit weird that we're showing it as, or we'll take a look. So, chroot var lookup. Oh, right, the pass WD thing. So let's just copy those in. T var lookup etsy. All right. Oh wait, that file path was totally wrong. What am I even doing? Funny that the shell fails to start if there's no pass WD. Okay, so pwd. Now I'm in var lookup. That seems all kinds of wrong. Like, why am I in var lookup? What does the shell actually do? We think the current root is var lookup. I guess what we should be doing is maybe we need to create a specialized custody here that doesn't carry the tail, because like the custody that we're setting as the root is /var/lookup, and really we should probably, it should just be slash, right? So that it forgets all of that, where it actually comes from. So let's try that. Custody create, no parent, no name, and it's the directory or error.value.inode. So we are synthesizing a new custody, uncached, with no parent. So yeah, this makes more sense. Starting at the inode that we resolved the path to. Okay, so how does this look now? Starting from chromody 1 to 55. But I'm still doing id. Why am I able to do id? Starting from it's like it loses the no, the current root never changes. Shit, okay. Why is it like that? What am I screwing up here? It's like something obvious, but what? Why do you think that the crum ID is 1, 2? That's the real root. Why don't you think that it is 1 to 55, which I guess is the 255 is the lookup. Why don't you? Current root inode identifier. Guess we can do something more here. And what's that inode ID? All right. That's a bit annoying to be confused by these things, but let's try to make some progress. Usually if we just print things, then it can tell us something. Alright, you jackass. Oh shit, wait, hold on a moment here. Chroot does a set root directory. And id but does the root not propagate to children in fork? Did I not set that up right? When we fork, new process. We pass the, oh shit, we don't propagate it to children. Well, that's not gonna work if we don't do that. Jeez. That explains why if you are browsing around, then the shell always sees the stuff that we want it to see, but whenever he forks to execute something, then like the child process suddenly sees everything. So, aha. Now there is nothing. Except the shell built-ins. So we can tab our way to things. Can we... Oh, we can't cat or anything. Can we even read something? We can run another shell. I don't like that it puts us in the empty space. Okay, but this is working, so that's really nice. So the bug was way simpler than I thought. It was just that we were forgetting to propagate the root directory on fork. Good. It's good that it was something simple. So why is it like this though? This is really strange. PWD. Where did PWD come from? GCWD, which comes from where the heck does it come from? On startup, do get CWD, and presumably get CWD is messing this up. And for him, we just do current directory.absolute path. So it's really weird that absolute path seems to be a little bit broken sometimes for slash. Why is it that way? So we walk the custody chain, but what if the chain is, oh, what if we're actually in the root? Then there will only be one entry here. So I guess we can simplify this a little bit and say like if parent return slash. No need to go through all that jazz anyway. And there we are. No freaking commands available. Very, very cool. So let's see if we can copy some commands in. So we like copy bin id into var lookup bin, and let's also get ls. And why don't we get cat? Oh. Don't know how that happened. Okay, let's chroot. Id. Can't open Etsy group. That's funny. Can't ls either without that. Can we cat? Yes, we can. So we can cat Etsy past wd, and it's there. But group is not. How cool is this? We have a working chroot. Of course, there's no chroot command to get us out. So, pretty cool. Okay, so this has been a bunch of things already. Let's commit some stuff. So let's just add that little custody absolute path serialization fix. Custody absolute path, always return slash for unparented, or for root, for roots. A custody with no parent is always a root, although not necessarily the real root. Anyway, then we got all of those fugly things I did with checking all the debug output, tap. Okay, so basically in path resolution, we now take into account, we use the current process's root directory instead of the root of the entire virtual file system. It's pretty simple, but I think that works. And of course, when we fork, we have to make sure that we propagate root directory to the child. Makes sense? And same thing when we create a new process. This is a special code path for when the kernel creates a new user space process. It's only used during kernel boot to create the initial system server process. But we have to set up a root for him nonetheless. And then making sure that we delete the root directory custody in the finalize stage of process destruction rather than in the destructor, because we can only take locks in finalize, and custody destruction requires taking a lock. Okay, and here is the chroot syscall. Very simple. If you're not super user, you cannot chroot. Other than that, we just get a syscall path argument from here and try to open it. If it works out, then we create a new pristine custody object with no parent, with no name, and with the inode, underlying inode of the directory that we found. That's good. And then we have the process root directory getter. And of course, if you don't have a root directory, we'll just give you the VFS actual real root. Remove that debug output. And then just the process.h stuff, adding it to the syscall list. Okay, so this here is stuff that we're not going to commit right now. And then, of course, setting the root directory of the initial init code. Okay. Root. Okay, so kernel plus let's say kernel. Add a basic chroot syscall. The VFS now uses the current process's root directory as the root for purposes, for path resolution purposes. The chroot syscall now allows super user to isolate a process into a specific subtree of the virtual file system. This this is not strictly permanent, as it is also possible for a super user to break out of a chroot, but it is a but it is a useful mechanism for isolating user unprivileged processes somewhat. All right, I just like that. Okay. Root is stored as a custody, as an uncached custody in process object. Cool. Okay, so now we got chroot. Maybe we should make a little man page about it. Why not? I quite like making man pages lately. So let's start with this one. Chroot. Change file system run shell in with a different file system root. And the example should have the hash, obviously, since it only works for root. And what do we say here? This program uses the chroot. Wait, how do we make links in these things? I forget. Chroot to, oh frick, now we gotta write another man page about that, but it will be good to write some man pages. We don't do enough of this. Did you notice that our man pages are markdown, by the way? Pretty cool. So syscall to switch switch into a different file system root and spawn a shell inside it. There are no options. Chroot var lookup or chroot var chroot. I don't know, what should be the example? Where are chroots? Something like that. work unless there is a bin shell available inside the root. Okay, I'm not the best in the world at these things, but it is nice to do these things. So we should probably, actually, let's use the mouse. Plop. All right. And then we gotta write that frickin' other sys man page, man 2. I don't know, we'll take the pipe one maybe. Chroot, change file system root. Chroot changes the file system root of the current to a new directory. Specified by path. And, oh gosh, do we want to write an example? I'm not in the mood for that. But we can write out some errors. Do we have some errors here somewhere? So this is how we normally do these. Oh, frick. So that would be default that the oopsie doopsie path is not a readable address. Not in readable memory. And eperm the current process does not have super user privileges. And all of the usual path resolution errors may also occur. All right. Nice. Let's see how this turned out. If we look them up in the help browser, which I love, by the way. Chroot. Look at that. Isn't this just so pretty? I love that we have a help browser. You can jump between them. So nice. And actually, Sergey recently went and made it themable, or so that like the HTML view here actually respects the themes. Although I realize now that we should probably make it care about link colors as well. That's a whole other thing. But that's lovely that we got the man page done. I feel like such a good boy right now. Okay, so we'll add these. Add a little chroot utility or type chroot program. This program changes the current file system root and spawns a shell. Cool. So what did I originally want to do? I wanted to take the lookup server and run him inside of the chroot just to see what would happen. So I guess to make that happen, let's do the system server ini. So we have the lookup server right here. What if we say that you're going to run inside of a chroot? But he needs his files. That part is a bit tricky though. So what if we were to run him in more lookup? What files does he need? Lookup server. Maybe this is not right for lookup server actually. We open etc hosts. Yeah, this kind of feels more like a something for like unveil or something like that. Like the OpenBSD unveil, what's this called? We could use that to restrict the paths that we could open. Oh, we don't have that syscall yet. But yeah, so we would need etc hosts. But if we had etc hosts, then we would be good. It's actually kind of interesting. Because I'm thinking, get rid of this stuff, or what if we had etc host there? Let's just put it in there and see how it would feel like to have this. And then in the service in system server, we're just going to play around with this at the moment. I'm not sure that we'll use this, but we'll try it out. So say chroot. And where is all the parsing of arguments here? Chroot is config read entry name chroot default to slash, or actually default to an empty string, the null string. If chroot is not null, we don't have to do anything here. We just have to remember it for when we spawn. So after we fork, we are the child, and in the child we want to chroot at the very last moment. So maybe here, if chroot is not null. Oh shit, actually we gotta do it before we drop privileges because we are root. We are the super user until here, set UID. So so if this fails, fail to chroot. Sorry, that's definitely an exit condition. Oh frick, this is a big rebuild for some reason. What did I even change? I guess some libc header, probably. The fact that it needs to open etc host is a bit annoying because like we can't bring it with us. one interesting option, I mean, it doesn't feel like a good design, but like you could imagine a system server opening it on your behalf. So like open let's see, hosts, and you could like specify a whole bunch of these things like foo bar and so on, and it would open these things for you and pass them to you as like already open file descriptors. But I'm not sure that that's a very good design. It feels very hackish. But I don't know. Maybe it isn't. Another option is to let lookup server start as root, and then have him open etc host, and then he would do the chroot himself. But it's always nice if you can avoid running as root even for a split second. But yeah, it's an option. We could conceivably chroot and drop privileges in lookup server. I don't know. I don't have a lot of experience with this kind of stuff, and it's very interesting. But I need to look at what other systems are doing with this type of stuff, because it's clearly useful. It's just, what's the best way of doing it? Anyways, we're just gonna experiment and see if we can make it do the thing. And then we don't necessarily commit to it, but it'd be interesting to see if we can do it. So assertion failed, false in spawn. Wow. Oh shit, yeah, of course, because oh damn, I'm stupid. We're trying to exec, and exec is not gonna work because I just chrooted. So I can't chroot like that. All right, well let's just play the other way that I said that. Let's run him as root, and we'll tweak the permissions. We'll tweak the permissions somehow after we log in. But obviously we can't do this. This is not going to work. So I should have realized. Okay, so chroot be gone. And then in lookup server, I think basically here we'll open. How does he expect this object? Load etc hosts, right? So we'll pass him an already open file, I think. Or yeah, that'll be the best. Okay. Oh wait, shit. Now we're opening config files. But those are the only ones that we do. Okay, so we can open those beforehand. So we do a cconf. Was that something big in there? It's just one parameter that we need. Okay. C file m host file. Load etc hosts. And we'll just take it here. So like a non-null refer to C file, host file. And we'll take the DNS IP address as a string. here we gotta open that up. Libcore, C file. Hosts file, C file, construct at C hosts. And that's the host file. And the DNS IP, which we'll get for app lookup server. So this could be done way better than this, but we are just trying something here. I keep saying that we're just trying something, but trying to convince myself. It's just an experiment, you guys. Okay. And then what am I trying to check? Hostschool.com. I can't connect to it now because the lookup portal is now owned by the root group. So we have to chown. We want to make it group 10. So 10 portal lookup. Okay, so now we should be able to connect to it. And that worked. Okay, so we're still good, but we didn't chroot yet. So we got a chroot like this. And then we gotta drop privileges to U8 10. String. No, what is it then? Stdio? Okay. Oh, we got a chadir. And we don't need to bring the hosts with us, nor the past WD, nor anything. Just an empty directory. Temp. So, who is running the lookup server now? Oh, nobody. Right. Oh, frick, that was not the right thing. I wanted to do that, and hostschool.com. Still can't connect. Why not? Oh, wait, did my chown not work? Oh. Okay, now we can't bind. That's interesting. Oh shit. Lookup server uses a C-local server. Calls takeover from system server. Calling listen. Wait. Oh, wait, hold on. Is this because of the RPC server? I guess it is, yeah. So we're trying to set up an RPC server and it doesn't work because there's no /temp. That's kind of funny. We can work around that by making a temp directory. This is starting to get really strange now. I just want to see it actually working without access to the rest of the file system. Oh wait, did I even test the right thing now? Wow, this is starting to feel a little bit sidetracked, but at the same time, this was the very first thing I said in the video, that this is what I wanted to do. Oh, hold on. Why does that fail so much? Can't listen. Var lookup. There's temp. Oh shit, but I guess I can't create a directory in there because I'm not root. I mean, I can't create a file or a socket or anything. Alright, we are just having silly problems. Sync, run. Come on, you guys. We're so close. So close to this strange thing. And it works. Finally. So who is running this show now? We sort by PID, we have lookup server running as lookup. That's good. He has a socket open. He has temp RPC21 open. Of course, we shouldn't see that if we go to rtemp here. There's no RPC21, but if we go to var lookup temp, we find his RPC socket. So the lookup server process is now confined inside var lookup. That's pretty cool. So this is all he can see. And he doesn't have a shell or anything. So he can really only see this. I don't know. What do you think? What do you think about this concept? Is this something worth like refining and figuring out a nice way of doing? And then just trying to isolate all of the different servers in their own CH roots, so that unless they actually get root access, they wouldn't be able to access the rest of the file system. There are nice things about it, I think. I quite like it, but it's a bit cumbersome. But yeah, I guess it would be neat if you could see somehow what the root was of a given process. Because right now you kind of just have to trust it. It should be good if you could go in like proc and then here. If you go, if we were to go in proc 21, if we would have like a root symlink that would point us to his root, That'd be really nice. So why don't we implement that? Let's come up with something. So that will be like procpid cwd, except it will be root instead. And I think what's the nice way of doing this? Root directory for procfs maybe, because then we can cache. If we ever overwrite it, then we'll cache whatever we were overwriting it with before we throw away everything before the slash. So something like for procfs and directory for procfs. If there isn't one, then for procfs is just going to be root directory. Otherwise, when we override it with the chroot here, so we're creating this new custody, right? So we want to do like a little bit of a root directory for procfs. Is directory or error value? Maybe there's a better way of doing this, but it seems downright reasonable at the moment. Okay, just jumping through the hoops of adding a symlink to procpid. Root, and this would be root directory for procfs. All right. I bet Linux has this already. They have root. Yeah. They do exactly this thing that I'm trying to do. This will be interesting. So first off, I can't do this unless we actually change the permissions so that it's in a group that I'm a member of. Then I can do that. And let me become root and go to proc. And look at that. We can see where he's rooted. That's so neat. Love it. Oh shit, no, we don't want to do all those changes. Just this little hack to expose it in procfs is fine. Yeah. Suppose expose a process file system roots as a procpid root symlink. Processes file system root. That's pretty nice. In order to preserve the full absolute path, we cache stash away we save custody used by chroot before stripping it to become the new slash. There's probably a better way to do this. Okay, so I think this is going to be it for today's video, and I don't think I'm going to be committing these lookup server changes right now. I just wanted to play around with it and make something nice. And it's pretty cool, but not super happy with the implementation. So we'll defer for now. But the chroot stuff, very, very cool. I really like it, and I think it's going to be a useful feature going forward. So thank you for watching, for hanging out. I hope you saw something interesting here today, and I'll see you next time. Bye.